All right, guys, so let's go ahead and begin Chapter 10, Section 5 on trigonometry and area. You'll remember that area of a polygon is going to involve the apothem. So to start with, we'll do the first problem in the book where it says find the area of a regular nonagon with 10 centimeter sides. Well, a nonagon is very hard to draw. Let me erase it a little bit. So we're going to do our little partial side like this. And then we're going to use this to represent half of one of our central angles and make it a right triangle. Well, if each side is 10 centimeters, that means this half side is 5. My apothem is there. All I need to do a trig calculation to find that apothem is this half of a central angle. Well, we've got 9 sides, so 360 degrees divided by 9 is equal to 40 degrees. Half of that is a 20-degree central angle. So now we can write down our formula. Area equals 1/2 perimeter times the apothem. And we can start filling it in. That means that my area is equal to 1/2. My perimeter is 10 centimeters per side times 9 sides, or 90, times the apothem. Or another way to write the area is 45 apothems, because half of 90 is 45. We just need that apothem. So let's figure out the apothem. Let's go through our trig ratios. SOHCAHTOA tells me an opposite over an adjacent is going to be a tangent, which is very common. So the tangent of a 20-degree angle is going to be equal to my opposite side 5 over my adjacent side, which is my apothem. We're going to multiply both sides by a to get it out of the denominator there. Cross it out. And now I've got a tangents of 20 degrees equal to 5, which divide both sides by the tangent of 20 degrees means that our apothem is equal to this cancel those out, 5 over the tangent of 20 degrees. Take out your calculator, find out what 5 divided by the tangent of 20 degrees is. Whatever you get, you're then going to multiply by 45. And if you round to the nearest square centimeter in this case, you should get approximately 618 centimeters squared. So there's the first problem. Just remember that apothem, how you find it, and how to find your central angle. And let's do the second problem in the book. Sorry, it takes a second to erase. This is actually my second go at this particular lesson because the first one was a little bit over 15 minutes, so I'm going to cut it shorter. Second one says, okay, find the area of a regular stop sign. Well, a stop sign we all know is an octagon, but that again is kind of hard to draw, so I don't need that. Instead, they tell me that a standard size has a 16-inch radius, 16.2-inch radius, excuse me. Okay, notice that it did not say the side this time, it said the radius. So now we've got 16.2 there. We do not know the area of the stop sign, which is what we're trying to find, nor do we know the length of one side. Okay, but we do need the apothem there, and we do know how to figure out a central angle. Okay, so 8-sided shape. You're going to take 360 degrees and divide it by 8. A central angle is 45, which means half of that is 22.5. All right, so a different calculation. This is an adjacent side over the hypotenuse. So is opposite over hypotenuse. Cosine is adjacent over hypotenuse, so we're going to use a cosine calculation. Cosine of 22.5 degree angle is equal to my adjacent side A over my hypotenuse 16.2. All right, so I now have my cosine calculation. I'm going to multiply both sides by 16.2, and basically my apothem is equal to 16.2 cosines of 22.5 degrees. Well, let's plug in my area calculation. And we're going to realize that we're missing something, because I need 1/2 my perimeter times my apothem, which is the 16.2 cosines of 22.5. So I've got an extra step. Here's what I would do. I would label this down here an x and find that x2. That x is going to give me half of one side, double it, and then multiply by the number of sides to find the perimeter. So that is an opposite over a hypotenuse, which is a sine calculation. So the sine of 22.5 is equal to the opposite side x over 16.2. Multiply both sides by 16.2. Cancel those out, and your x side is equal to 16.2 sines of 22.5. Now, at this point, I'm still using my area calculation of 1/2 PA. Remember that that calculation for x has to be doubled and then multiplied by the number of sides, which is 8. So 16.2 on your calculator, sines of 22.5 degrees, hit enter, times 2, hit enter again, and then times 8. And it ends up with my perimeter being kind of an ugly 99.19154. That's an exact number. So let's go ahead and divide that by 2, which is like multiplying by 1/2. And you get about 49.595. And then let's multiply that whole number by the apothem calculation of 16.2 cosines of 22.5. Hit enter again, and you should get approximately 742.29. In this particular problem, I can't remember if it was, it was centimeters or is inches on this case. All right, so there's a second example where they give you a radius instead of a side or half of a side or anything else. We've already done a lot of these. When I first taught you the apothem, I went ahead and taught you how to handle problems that are missing more than just what was in the initial section. So hopefully this is something that, while it's a somewhat difficult assignment sometimes, will not cause too many problems. Erase all of this. Let me check and see how I'm doing on time also. 8 minutes, so I've got enough time, I think, to finish up. Now, finally, we've got to be able to get this theorem 10-8. Let me show you where it comes from. There's another way to find area using theorem 10-8, where you have A, B, and C. Here's my height right there, okay? Well, that's the A side. This is the B side. This is the C side, okay? If you will go ahead and do a trig calculation for the measure of angle A, you're going to find that the height right here, the height is equal to the sine, which is opposite over the hypotenuse C, lowercase c. So it's sine of A. Well, I'm getting a little bit mixed up there. Hold on, let me erase that. I'm trying to save time on the video. You'll find that the H is equal to C sines of A once you do the trig calculation. And you could solve that and see that for yourself. It's even in the book if you need to know more. When you plug that back into area equals 1/2 base times height, well, now we can take out that height And we could instead say that area is equal to 1/2 base times C sines of A. I'm going to run out of room here. Right there. And so we're going to use either of these formulas to find area. All right, let me show you how a problem works. Erase real quick. Let's check my time real quick. And I've still got about 4 minutes. Should be enough for one problem. So we end up with a triangle. Doesn't matter the configuration of the triangle. But in this case, they give me 12 here, 21 here, and an angle of 48 degrees right here. Okay, well, wherever the angle is, that's where your A has to be. So that makes this A, this B, and this C. And that means that the B is there and the C is here. So we're just going to plug it into our formula. A is equal to 1/2 the B side, which is 12. And then C sines of A, C is 21, or 21 sines of 48 degrees. And at this point, guys, it's just calculator. 1/2 of 12 is 6. 6 times 21 is equal to 126. And so the area is equal to 126 sines of 48 degrees. And we now have a separate way to find our area using a shortcut variety. That's actually all the examples in the book. Again, this can be a little bit of a tricky section, so don't be afraid to ask for some help, especially if you've forgotten some of your trig. You can see now why we spent so much time trying to memorize and be able to use those trig ratios. So we'll stop it here. Hopefully this will help, and then contact me via text or email if you've got any questions.